How is it possible that buildings constructed 2,000 years ago are still standing today, while some modern structures begin showing damage after only a few decades? The answer lies in one of history's greatest engineering mysteries: Roman concrete. Ancient Romans built massive structures that continue to amaze the world. Aqueducts, bridges, temples, and even harbors have survived earthquakes, storms, and centuries of exposure to the elements. One famous example is the Pantheon in Rome. Completed nearly 2,000 years ago, it still possesses the world's largest unreinforced concrete dome. Modern engineers have long wondered how Roman builders created such durable material. For many years, scientists believed volcanic ash was the main reason. Romans mixed lime, volcanic ash, and rock fragments to create their concrete. Volcanic ash from regions near Naples contained unique minerals that strengthen the material over time. However, recent research revealed something even more remarkable. Roman concrete may actually heal itself. Scientists discovered tiny white fragments known as lime clasts embedded throughout ancient concrete. For years, researchers thought these pieces were simply mistakes made during mixing. But they now believe these fragments were intentionally included. When small cracks develop, water can enter the concrete and react with the lime clasts. This reaction creates new minerals that gradually fill the cracks. In other words, Roman concrete has a natural self-repair mechanism. This process helps prevent small fractures from growing larger. As a result, structures become stronger rather than weaker over time. Modern concrete behaves differently. Today's concrete often relies on steel reinforcement. Although extremely strong, steel can rust when exposed to moisture. As corrosion spreads, cracks appear and structural damage increases. Many modern bridges and buildings require costly maintenance after only a few decades. Roman concrete, on the other hand, appears to become more resilient with age. Marine structures provide an excellent example. Ancient Roman harbors have endured constant contact with seawater for centuries. Scientists found that seawater triggers chemical reactions inside Roman concrete. Instead of causing deterioration, these reactions create new minerals that strengthen the material. Researchers are now studying Roman techniques in hopes of developing more sustainable construction materials. Modern cement production generates significant carbon emissions. By understanding ancient methods, engineers may be able to produce stronger and more environmentally friendly concrete. This could reduce maintenance costs and extend the lifespan of future buildings. It is fascinating to think that an innovation created over 2,000 years ago might hold the key to improving modern construction. Roman engineers achieved extraordinary results without computers, advanced machinery, or modern technology. Their knowledge continues to inspire scientists and architects around the world. Sometimes the greatest innovations of the future come from rediscovering the secrets of the past.